Well, everybody, while we're waiting, let me at least get through some of the startup conversation. First off, we're going to be recording this conversation, and I do appreciate you attending today. We're talking about electrification of buildings, and we've got Pat Karras with us. He is with Multistack. He is the regional manager, Western regional manager for Multistack. As you might be able to tell from a few gray hairs that maybe he and I both share, but Pat, well, he's been around in the industry for quite some time. As far as today goes, we will accept any questions that you might have on the topic. Please type them into the chat, and then I'll work them into the conversation towards the end. And then once we're finished with the questions, we'll open up the lines if you want to spend more time after our 15 or 20-minute presentation, and we can go from there. Yeah, definitely hold the questions till the end. But as a reminder, this is a semi-weekly coffee break that we are doing with Long. We've been running pretty well as far as the past year goes, or this 2021. And we have Didanko set for next week, and then a few following that for Chilled Beans. So please do join us for future ones. But at this point, Pat, are you ready to go?
I believe I'm ready to go. I got all my technical glitches figured out, I think, at least for now. You'd think the gray hair, I would be farther along with some of this stuff, but not always. Yeah. So
well, thanks again for attending, Pat, and whenever you're ready to start.
I will. Well, thank you, Jeff. Thanks for the invitation. I very much appreciate the opportunity. We are very, very pleased to have begun a relationship with Long last year sometime, but obviously with all the madness of COVID and whatnot, it's certainly been different for all of us, but we are thrilled. Long now represents Multistack in Colorado, Utah, Montana, and Wyoming, and we've kind of consolidated and changed partners, and we're thrilled with how things are going so far. So when Jeff and I were talking about this, what we thought was important was to talk about this concept of electrification and how what we're seeing in the industry as far as trends and what Multistack has been doing for some time now, quite frankly. The product line that we have fits quite nicely into this push towards electrification. So not too much of a commercial on Multistack, but more about the trends that we see. And what you'll find is we do have some nice products that will be useful along the way here. So what does it mean? It means a lot of different things to a lot of different people, but essentially it's the process where all of the end users for heating and cooling currently powered by solid, liquid, gaseous, fossil fuels, et cetera, are heading towards being powered by electricity instead. And a lot of places in the country have already gone down that path, and I've got some examples that I'll share with you. But it's kind of a long term, but we're nicely positioned to help you and your customers benefit as this trend starts to materialize. There's a big push right now to get rid of natural gas. And it's taken all of us probably a little bit of time to get our arms around, what's wrong with natural gas. I came from the utility industry and then from Emerson Climate Technologies, Copeland. And natural gas was always a positive fuel. It was fairly clean. It was used in cogeneration, small fired facilities, but there's a bigger problem with natural gas. It does emit carbon dioxide, which is one of the main greenhouse gases. We're also starting to see people pay more attention to methane as well. It's a little bit more short-lived, but it also has a dramatic impact as well. So lots of the conversation revolves around carbon dioxide and methane. And the biggest concern that folks have is in old situations, in old applications, there's a lot of leaking pipelines from old urban infrastructure. So, gas is likely going away in many places where it's less safe and less well taken care of. In July of last year, geophysical research found that methane emissions were twice what we had estimated. And so that's part of the reason we're starting to see methane enter into the conversation a little bit more. Most of the emissions are coming from old gas pipelines and leaks inside residential and commercial buildings. And then the people laugh about it, but livestock is a prime source of methane emissions. And we'll not go any farther than that discussion, but livestock emissions are a challenge as well. It is happening today. Electrification is happening today. Berkeley, California, I believe Boulder, Colorado, closer to you all, starting to take steps towards removing natural gas from the fuel mix. New Jersey has a master plan trying to end natural gas use. So it's not just new applications with natural gas. Some of it is actually stretching back all the way into existing applications and getting people to change out their equipment. And obviously that's going to be towards electricity. A lot of work to be done, lots of teeth gnashing likely to occur along the way, but 8 states, Washington, D.C., Puerto Rico, all have established clean electricity goals. The big strategy, especially in New York City, if you look at the composition of energy use in New York City, 67% of energy use and emissions come from commercial buildings and homes, smaller in cars, and 3%, very small, with refuse. So the big hitter, the big impact is in buildings, whether they be commercial or residential. And so that's where a lot of the focus is today. New York City, they have a Climate Mobilization Act. This is just one example of a number of them out there. Tighter limits on greenhouse gases by 2050. All of the roofs have to have green roofs or solar systems going forward. All buildings are going to have to start to post energy efficiency grades, and they're going to actually subsidize sustainability with energy loan programs. So New York City and New York State in general, taking some pretty serious action with respect to electrification and controlling emissions. So it's coming, but it's really already here, quite frankly. Berkeley, first city in California to ban natural gas in new buildings, and we are seeing it. I have the West region, which is essentially the North Pole to El Paso, Texas, and everything west of there. And we're seeing a lot of it. Berkeley, I mentioned Boulder as well, but Berkeley's no longer going to allow natural gas in new buildings. That started January 1st of last year, 2020. It makes up a significant part of Berkeley's greenhouse emissions and 70% or more of its building sector emissions. But unfortunately, they're already behind in their plan. Some of that due to just the impacts of COVID and their ability to press the envelope in terms of getting things done. But Berkeley's there, and lots of others are coming. So I think it's there. It's coming rapidly. California tends to lead on a lot of these things, but the state of Washington has put in some new, stronger codes. We're starting to see it in Oregon. I have Western Canada as well, and I'm seeing a lot of activity in British Columbia. So it's kind of starting from the coast and starting to move in. The good news from where we sit at Multistack is that we have half a dozen or so ways to help with the heating needs that are going to have to be addressed as natural gas is taken out of the mix. We have a water-to-water heat pump with reversing valve, and kind of from top to bottom, we've been doing water-to-water heat pumps for probably 20 years. So the technology, the heat recovery concept, is not new, and it's not really rocket science either, but we've been doing it for a very long time. We also do something called dedicated heat recovery. So the first machine is just a heat pump. The second machine, MSH, is a machine that does simultaneous heating and cooling with Copeland scrolls and some Danfoss variable speed scrolls as well. So we're expanding that product line for the market space. And these are water-cooled versions. The next one, Danfoss TurboCore, the magnetic bearing oil-free compressors, they have come out recently with what they call a high lift machine. And so we're able to do temperatures of 40-ish, 40, 45, leaving chilled water, and 120 degrees, hot water. So that high lift compressor is starting to get some traction in the market space. We've been working with TurboCore since their inception in the US, about 20 years now. And this new machine is going to help us immensely on the heat recovery side of things. We've been selling that type of equipment for just under a year right now. So it's still new, but it's coming up rapidly. Switching over to the air side, we have an air-to-water heat pump. And then we also have a similar machine to the MSH. We call it an ARA, It does the same kind of heating, cooling, and simultaneous type of application that we discussed with the water cooled side. So lots of ways to get at those heating requirements in your space. Just some pictures of what the equipment actually looks like. This is the water-to-water heat pump, various sizes from 10 to 80 tons. Refrigerants, 410, 134, quick diversion on refrigerants. We also do 513A today with the turbocore machine. So we're getting into the new refrigerants. That's being dictated to us by the compressor manufacturers. Whatever Copeland and Danfoss do with respect to refrigerants, we're able to do and to go down that road. But they are driving that decision for us. So we don't get much impact because we're not a Copeland and we're not a DuPont or any of those guys. The heat pump with reversing valve, basically, a schematic of what that might look like. You've got a source sink, you've got load side, either heating or cooling. Pretty standard heat pump like you're used to seeing. This is the dedicated heat recovery machine, which can do both heating and cooling. And when you properly size it, it'll control to the smaller of the loads, and then it'll manage the bigger of the loads. The challenge here is you do have to have both a chilled and a hot water load. And now the lift is actually starting to grow, but these are done with Copeland scrolls. And now we're getting into Danfoss scrolls as well. We launched a new heat recovery product that as I mentioned, back in 2020 at ASHRAE. So this is what that machine might look like. And I mentioned 134A is the standard for that machine. 513A, drop-in refrigerant for the most part, a little bit of a hit to efficiency, but not huge. And we're actually able to heat up to 145, depending on your leaving temperatures on the other side. And this is, basically heat recovery in a nutshell. You've got on the bottom a heating load, a boiler. On the top, you've got a cooling load. And our principle is let's help that along. If we can take care of both the heating and the cooling loads, we'll do that. But a lot of times the requirements are bigger. And so effectively, we're helping out with heat recovery. You've got some heat, rather than exhaust it, let's circle it back in and let's use that in the cycle and use what you've already paid for, quite frankly. So there are some very significant energy efficiency plays to be addressed with electrification and then the heat recovery machines that we use. I think everybody knows what heat recovery is, but it is actually being mandated in 90.1, especially in certain applications like hospitals. And Mayo Clinic, that picture on the screen, that was done about 20 years ago. So echoing the fact that we've been doing this for some time now. We've got the ability to plug it in, show you the energy savings. So you get an analysis from us. There's certainly more to deal with, but you get a sense of we're beyond just offering, but being able to give you the tools to analyze savings potential. The things you have to consider in a DHRC, dedicated heat recovery chiller. Can you use the water loop on the evaporator? Is there solar, boilers, data center applications, lots of places where you might be able to use that chilled water in a heat recovery type of application. Some analysis has to be done on the front end to understand the loads, but in general, we've got a lot of experience doing it, and I know Long will ramp up very rapidly if they're not already comfortable with heat recovery types of stuff, which I'm pretty sure they are. So, Jeff, how are we doing on time?
You have 1 more minute.
Okay, perfect. This is what the heat pump machine would look like, an ARP, just a straight heat pump. This is the other machine called the the heating and cooling machine. Notice that there's 4 pipes. One is hot, one is cold. The way this machine works is there are 2 separate heat exchangers and then a condenser bank. When you're heating, you're pulling heat from the outside air, running it through the heat exchanger. When you're in the cooling mode, you're exhausting the excess heat through the fans and through the condenser. And when you're doing simultaneous load, you don't even use the fans. You actually exchange the heat between the 2 heat exchangers on the inside of the machine. So that's what that machine might look like. Additionally, one of the problems we found was at low ambience, it was tough to create a lot of hot water. There's a new compressor we've been using since 4th quarter of 2020 that allows us to do 0 Fahrenheit all the way up to about 145 degrees hot water. And that is going swimmingly well. other than we need them to make us a bigger compressor. Right now, that size limitation is a 30-ton machine, 2 15-ton machines. So, Jeff, I think I might be out of time.
Well, I appreciate the information. It brings up a lot. And, we see from what Berkeley is doing, a very similar initiative here at the University of Utah, in the state of Utah, that there's a lot of push towards this electrification and trying to reuse load that's already put into the loop from other buildings through their condenser water or their chilled water loops. So large campuses can certainly benefit from something like this, but even down to smaller buildings, if you do have a source, dry coolers or other heat source that is, let's say, low grade, you can use these type of systems to make them higher grade, which is certainly easier to heat with. So I think that's a good takeaway from this whole thing, and look for opportunities to do that. Now, a question or so for you, and let me remind everyone, if you do have a question, please type it in and we'll get through all of them. But a question I'm often asked is about refrigerants, Pat. R410A, 134A. What does your crystal ball say about those particular refrigerants and how much longer they're going to be available?
Well, it's kind of a cloudy crystal ball, to be quite honest. As I mentioned, earlier, we're very much driven by what the guys at Copeland and at Danfoss are doing with refrigerants, and they've been testing lots of different things. Where we see things headed, based on and we're very close to the Copeland folks. One, because I used to work there, so I stay in touch with those folks. But 513 is kind of a transitional refrigerant, we believe. It doesn't have, it has low enough GWP, under 750, but we also think that the industry is headed towards 0 GWP, at which point we're starting to talk about 1, 2, 3, 4, and all of the alternatives, ZE, YF, all of that. We've actually done applications with 513, and these are all turbocore because they're medium pressure type refrigerants, but and we've also done jobs with 1234. So we've got experience with both of them. On the scroll side, they're leaning towards some variants of 450-ish, R32, a couple of things in that camp, but there's not really clear direction yet from those guys. So the good news is whatever they decide, whatever they're testing, they let us be part of that conversation. We plug it in to our models, and it still fits into our software selection program. We've done more analysis on the medium temp stuff with turbocore than we have with scrolls. We've really not, they're not clear enough yet on where they're headed. But that is coming. It's all about two things, GWP and flammability. Historically, all this stuff's been A1, and now some of what they're talking about is A2, A2L, I believe, which is mildly flammable. I don't know what mildly flammable is, but it still sounds scary.
Well, a lot of the new refrigerants are actually mixing in flame retardant refrigerants to lower that flammability. So yeah, it's quite interesting the mix that we're going to see in the next 10 or 15 years for certain.
Yeah, now, we're as ready as we can be. We don't know what happens to pipe sizing or overall efficiency on some of the new ones, but we're ready to run with it when it's made available to us.
Now, one term that I've always struggled with is this chiller acronym that we use. Dedicated heat recovery chillers. It doesn't sound right to me. I mean, at the essence, these things are really heat pumps. We're just pumping heat from one to the other. And a lot of times when we use them in Utah, we've been using them as just heating only, though they can be used, as you mentioned already, for heating and cooling. For a designer, is there any particular way, given that this is kind of a new thing, that they should, a terminology that they should use to try and differentiate this from the water-cooled heat pumps that we may have seen, the small ones on a condenser water loop versus the standard?
That's a great question. Yeah, I mean, I think we coined that term some time ago, and you might be right. It's possible that it's out of date and perhaps even confusing. I think we're starting to use the concept of heat recovery versus DHRC, but those who have been with us for a while have kind of gotten to, it's just second nature to them to refer to DHRC, and they're starting to slowly change their language too. So it's probably more accurate to just call it heat recovery, Jeff, and kind of think about it in that fashion. Because what you're really trying to do is you've already paid for that heat, and unfortunately, right now anyways, electric boilers are expensive and they're not as efficient. And so we're we're trying to find a way to maximize that dollar spend that you have when you have to do an electric boiler. So.
And I would submit for that recovery heat pump. I think that term, if you use that, an RHP, would differentiate it from, again, the standard heat pumps that we see. Let everyone who's bidding that project or in the market or even reviewing those documents know that it's something a little bit different, and you might be able to define a different term. I haven't thought through that too much, but just understand that that whole chiller thing is something that you might be able to manipulate depending on what you think is best to name these things on your particular drawings. We don't have any questions to this point, but I will at least end this part of the conversation at this juncture to say, first off, thanks, Pat, for your time. Thanks to all who attended. We're going to be posting these recordings as well as others to our YouTube website. So you certainly can join us there, or pro tip, watch that on double speed if you've missed this particular presentation, and you can get everything that Pat said in a much shorter time. But anyways, when you do have further questions or concerns, certainly reach out to your Long salesperson, and we'd be more than happy to drill down on whatever topic you might want, electrification or whatnot. So please do join us next week at 10:30. We're going to be talking about chilled beans with Didenko and their applications. It goes hand in hand with a lot of what we see here, as a matter of fact. And at this point, we'll stay on for just a few more minutes. If anybody wants to unmute themselves and ask us a question directly, you're more than welcome to.
Thank you, Jeff. Thank you, everyone.
Thanks again. So, Pat, we'll see most people probably log off at this point. We'll see if there's any other stragglers that want to ask a particular.
And, these presentations, you can have any of these at any time. Also, Jeff, we just ask that people don't take them and, mail them everywhere, but all of this is available to you guys at any time. So
Excellent.
Well, Jeff, you brought up all the questions I had.
Oh, excellent. I'm glad to hear, Michael.
Similar thing, Pat, where we just had kind of the circumstance Jeff was talking about, where having to explain to the client or explain to a lot of people that no, your heat recovery chillers are supplying the heating water system to the building was very unintuitive to a lot of parties.
Yeah. Well, and I will tell you, to be honest, one of the reasons we're very excited about working with Long is because they understand the concept, and they're willing to promote it. And to be fair, the states of Colorado, Utah, Wyoming, Montana, there hasn't really been a push up to recently to use or understand the technology. Energy costs were low. There was no requirement to do it. And any finance person is going to tell you, if it doesn't pay, I'm kind of hard pressed to do it. But we're starting to see that dynamic change.
And Michael, if you come up with a better nomenclature for this, I saw this, funny enough, with Cambridge. Cambridge makes a system which is called high temperature, high velocity, HTHV. And a lot of engineers were calling it unit heaters. And I beg the engineer, don't use unit heater, because that describes a whole different subset of features and devices, and it brings up a unit heater in someone's mind, something that is much less efficient, much less dynamic, doesn't do outdoor air pressurization and whatnot. I see a similarity here where I'm reluctant to call these chillers, because a lot of times, like I said, we're heating with the
exactly.
Yeah, the cold water in this case is just a bonus that we're rejecting back to the system that we're not even taking advantage of. So
right.
No, Jeff, I agree. We've pondered what's the best way to refer to it, but like you said, heat pump comes in so many different layers and levels of what you're using. But I do like Pat's point where we're saying recovery heat pump, I think, is a closer.
Yeah, that combined with the ability to do a rudimentary energy analysis, I get it, I understand, but what's it going to save me? And that little tool that I showed on the screen it's a very simple, quick tool for, you pop into an engineer's office and you just throw some numbers into it, and then they start to get their arms around it, and they go, okay, now I get it.
Now, Michael, you've been involved with all the multi-stacks that we've used at BioFire. We certainly see this electrification happening at the use more broadly, so I think we'll see more and more buildings there. WSU uses a different type of electrification with the VRF system, right? With the water system, which may have some pluses and minuses. Do you see any other broad use of this beyond those particular locations, at least in the work that you're doing now?
No, I think, yeah, those have been the two main ones that I've seen, like I said, BioFire and the U. A lot of the other, larger campus projects that we have, that they have their unique take on it, or how they are approaching their system and haven't been taking advantage of the heat recovery, or they do run at lower temperatures, so they don't necessarily could take advantage to any heat rejection at that point. But no, I think those are the two main ones.
Great.
I can't think of any others off the top of my head.
Well, do you have any other questions for Pat or myself?
I do not. Thank you both for your time. I appreciate it.
Of course,
Thanks for
anytime.
attending.